Sitting in the centre of the Railway Museum in York is an engine with easily one of the tallest chimneys ever preserved, and for an industrial engine, it isn't badly decorated. But before the Agenoria had a chance to grace the rails, it's important to know why this engine was vital to the success of one of the most industrious areas close to London. John William Viscount Dudley, known to most as Lord Dudley, owned land that was rich in coal and minerals. The land lay in an area of England affectionately known as the Black Country. The family and the landowners knew for a long time of the land's riches, however there wasn't a viable way to extract it. An accumulation of varying factors, however, forced a technological evolution, and the need for more raw materials brought in new mining techniques that allowed for deeper mining. Up until that point, the only option for moving raw material and processed goods in bulk was by canals. Canal services were in principle the start of freight transportation. For the first time, businesses could move goods to pretty much anywhere, even to ports that they would not usually have access to. But canals had limitations. They were tricky to build and almost impossible to move, and they were painfully slow. News was also filtering that the canal network was becoming congested, and while the Black Country had a flourishing canal network, it was only a matter of time before it too would not be able to cope with the projected output. The land surrounding the estate was equally as fruitful. However, the way the land was managed differed. For example, in Lord Dudley's case, he employed a mineral agent to oversee day-to-day affairs. But some landowners agreed to lease the land and take a cut from the men willing to work it. Now, one such person was a man called James Foster. He owned his own mining business, which he leased from a landowner near Shut End, as well as looking after some smaller ventures left to him by his late brother. Leasing the land meant he had an effective free rein to do as he desired. He also wasn't blind to the recent experiments others had done with steam engines. Railways were not new to the Black Country. Mills and business owners would use tram and wagon ways to get their goods from one local business to another or to the canal. The wagon ways were usually poorly made, with simple carts, and were either horse-drawn or hand-pushed. James was keen to bring the steam railway to the Black Country. Not only would it benefit himself in the short term, the railway was proven to be adaptable to the growing trades, but it was also more practical than canals, as being both easier to lay and simple to move. James wanted to start the railway near his business and terminate it at the Staffordshire and Worcester Canal. Canals were still the principal way to move freight, so a connection was vital, while other businesses like James was on board with the idea, but the line had to go over Lord Dudley's land. Lord Dudley was happy with this, but he was less than impressed that Foster wanted to build the line himself. Therefore, an agreement was struck. Both parties would partner up to build the line together, and on the 17th of January 1827, the partnership became official, with both sides signing the documents, and royal assent was granted. Lord Dudley and James Foster started to build the line together, but if either party had to move materials across others' land, fees to be paid went to that other party. The pair turned to engineer John Rastrick to both plan and oversee the building of the line. John was a superstar in the engineering world and was accredited with many large projects, including working with the Stephenson family on the Stockton and Darlington Railway. Rastrick had just finished overseeing the Stratford and Moreton Railway. The railway was one of the first that used wrought iron rails that were mounted on stone blocks. With the weight of steam engines buckling standard rails of the time, the railway stipulated that the rails must be substantial enough to take the new engine's weight comfortably. So John designed a new locomotive and asked the new foundry in Stourbridge to produce it. The foundry had only ever produced 4 locomotives, and 3 of them were sent to America. But the only one to remain in the UK was destined for shut end. For an early engine, this new locomotive was unique. For starters, it had not 1, but 2 safety valves. While one valve was exposed, the other was out of reach of the crew. The idea was to stop tampering and crews trying to tie down the valves in order to get more pressure in from the boiler. It weighed around 11 long tons and had twin 8.5-inch cylinders. The crossheads were guided by what was known as a grasshopper parallel motion. This motion was common in early locomotives, and many compared the new engine to the older Catch Me Who Can, which was designed by Richard Trevithick. The boiler itself was 4 foot in diameter, and the internal structure was basic. It had a central furnace tube which split into 2 flues, each one 18 inches in diameter. The hot gases from the fire would travel through these twin flues. The flues fed into a chamber at the front of the engine, where a vertical tube guided the gases to the chimney. The flues had a total heating area of 85 square feet, with the grate having an 8.5 square feet of heating space. The engine was also one of the first engines to use mechanical lubrication. Even the most polished of metals would heat up if they were worked against one another without adequate lubrication. Too much heat due to friction can cause severe damage. To stop this, the engine has to be lubricated. On many steam engines, lubrication wells are fitted. The wells were filled with a porous medium, and pipes would drip feed the lubricant to where it was needed. Another lubrication point is usually located on the motion itself and is normally capped by a cork with a reed. Cork is a great plug as it naturally expands, creating a seal. The reed allows air to enter and ensures the oil can drain freely. And the cork plugs were cheap and quick to make. Lubrication points and locations vary from engine to engine, but every point must be checked every time the engine is used. This is where engine knowledge is key. For example, Hunslet-built Austerity Beatrice has 12 corks as well as 8 oil boxes, each with 3 feeds. This is on top of 2 further boxes that feed the piston rods, which in turn feed 4 more points. Then there's 6 axle points and a steam oil displacement oiler, and even some of the levers have oil can lever points. And finally, 8 greasing points. This is compared to a pannier tank, for example, which would easily have double this amount, even though the pair have similar valve gear. Now, the new engine would have faced the same problem, so a mechanical lubrication was used. It was basic and involved 2 rings on an axle that were power level paddles to revolve around in an oil sump. This fed the oil to the axle boxes. The engine is dwarfed by the massive chimney, and the only reason it's so large was to create the required draft. And finally, to keep the engine balanced, new balance weights were moulded into the driving wheels, and even more unusual for an industrial engine, the wheels were decorated with an elaborate design and the engine's name, Agenoria, in honour of the Roman goddess of industry. After being moved by barge to shut end, it was trialled, and following those trials, the railway opened on the 9th of June 1829. As the rails were made with the engine in mind, the engine was a marked success and was able to pull several tons at an impressive 11 miles an hour. As the railway was made to a standard gauge, over time it was able to connect to other lines as they were built. Over the next 30 years or so, the Agenoria worked as a true powerhouse. However, with the inception of newer engines, it was decided to withdraw her in 1865. James's nephew William had taken over by this point and had paid for a revamp of the line and its stock. Agenoria was relegated to the shut-end yard. But in 1880, a man called Edward Binden Martin visited the yard and the ageing engine. Agenoria had been robbed and parts were scattered. From his notes, which have since been preserved, he noted that there was a cylinder missing and the frame's motion was in bits and scattered, but there was potential for reassembly. Edward appeared to have an interest in the engine, and thanks to a drawing he had made of her 20 years prior when she was still in service, he had a pretty good idea of what went where. As there was no plans, the picture would prove invaluable to create a working plan. Thanks to this and other accounts of the engine, Edward was able to put a case together to the Patent Office Museum, with a view to restore and preserve the locomotive for the nation. It took 4 years of persuasion, but in 1884, Edward got the news he was hoping for, and the office contacted William, and William was only too happy to donate Agenoria to be preserved for the nation. After a full restoration, Agenoria was presented to the Science Museum. The engine was moved to York in 1937 to be on display in the Railway Museum on Queen Street, and other than a brief stint away during the war, has remained in York ever since. Agenoria currently sits centre stage in the Great Hall, and its iconic chimney is hard to miss. Currently, it remains one of the oldest engines in the York Museum, even older than Rocket. Sadly, the tender was disposed of in 1897, but a replica was made, completing its look. And if you get a chance to have a look at her, take note of her finer details, especially the decorations. Taking into account other examples of her time, it would have made her visually stunning. It's not bad for an industrial engine.